My name is Liam English, CEO of Bluemetrix, and I'd like to thank you all very much for coming this morning. What we'd like to present to you is a product we have developed which automates the ingest of data onto Hadoop, the transformation, data quality, and data governance. And hopefully we'll show you a way to do this without having to write any Hadoop code. Before the main part of the session will be around a demonstration of the product. And before we do that, I'd just like to spend a few minutes and give you an idea as to who we are as a company, where we've come from, why we've developed this solution, and what it does. So, check to see, just one moment. Apologies there. No. Okay, great, thank you. So we're a Hadoop company. We've been involved with Hadoop for quite a number of years, and we provide a full range of services, from managed services, professional services, Hadoop products, Hadoop solutions. We first started working with Hadoop in 2009. So we were very, very early adopters of the technology. When we started working with Hadoop, the stack looked something like this. It was pretty basic. It was version 0.17. It had basically MapReduce, HDFSF, and a Hadoop core. Zookeeper was in incubation mode, and HBase was in incubation mode. There wasn't really an awful lot on the technology at the time. There was no security. There was some replication. There was very, very little availability. There was no Hive, so it was very, very basic when we started working with it. It was difficult to use, and it was still very much a research project at that stage. Things got a bit better when Yarn came out in 2013. The stack became a little bit more mature. You had Hive, you had Uzi, you had a number of more components on it. And I think we get to today where it's a mature product. It's very much, it's got 20, 30 different components. It's there and it's stable. In our opinion, it's a stable technology today. But if you listen to some people in Gartner and some of the analysts, they still talk about only 20 to 25% of Hadoop solutions being successful. So it is still difficult to use, and it's difficult to implement, but it does work if it's implemented correctly. Our view would be that the issue is not the stack. At the moment, it's much more about what you do with the stack, and it's much more about the data that's on the stack. If you go back to 2009, it was all very much around distributed computing. That was why people got involved in Hadoop. But over the last 2 to 3 years, there's been a big change in the whole environment, especially around GDPR, data governance, data compliance. And the issue is much, much more about what do you do with your data? How do you move it? How do you validate it? How can you guarantee the quality and the governance of it? So when we started working, in 2015, we started working with Hortonworks. We provide a lot of professional services to Hortonworks, and we've worked with about 150 projects over the last 3 years, mainly with big banks, financial companies, telcos. And as a result, when we started working 3 years ago, we didn't come across any data officers or any roles within the companies around data. But over the last 12 months, 18 months, everywhere we go, we meet data officers, and we meet people who are now responsible for Hadoop clusters, and they're responsible for what they do with them. And when you talk to these data officers, I mean, they're basically the owners of the data within the company. And I guess they have two main responsibilities. One is to ensure the data is secure, it's solid, and it's correct. And the second is to utilize the data to generate revenue for the company. And if you look at how they approach it, most CDOs have two strategies. One is a defensive strategy, and one is an offensive strategy. And the defensive strategy is very, very open to automation. It basically involves protection of the data, quality of the data, lifecycle management of the data, access to the data. All of these things are very open to automation, and that's what we've done here in this product, which I'll show you later on. The offensive is a little bit trickier to automate, because you're talking about developing models and you're developing use cases to use the data and generate new revenue, generate new businesses, but it is possible to do a certain amount of it. Like I said, in terms of defense, it's very, very easy to automate, and we've done quite a bit of it around data validation, data quality. Offensive, a little bit less so. What we have done is we've developed a product which we call the Bluemetrix Data Manager. And this is a product that works on top of a product from BMC called Control M. And I'm not sure how many of you are aware of Control M, but it is a workload automation scheduler. It's sold by BMC. It would be probably the #1 enterprise workload automation scheduler in the market, used primarily by big banks, telcos, financial institutions. We've taken that product and we've used its core functionality around scheduling, around reporting, around monitoring and error detection to build our module on top of it. Because what we're doing with the data manager, we're building a product that's focused on operations and production, and we wanted to build it on top of something that was very solid. There is Uzi in the Hadoop stack that exists today, and if any of you know it, you know how difficult it can be to use. So we didn't want to use Uzi, but on top of Control M, we've built 4 modules which automate the following functions. The first is ingest. This module basically automates the ingest of data onto Hadoop. It can use Scoop, Kafka, NiFi, whatever is required. And again, it will ingest from multiple sources, whether it's databases, Oracle databases, Teradata, SQL Server, JSON files, log files, whatever. We have a validation and a masking function, where we basically validate the data and we mask the data as we ingest it. Validation has 2 types. There's basically consistency validation, where we check the consistency of the data, that it's actually moved correctly without any issues, that it hasn't got corrupted in the move. And then we have integrity checking, where we can check the integrity of the data that is actually being ingested, and that would be checking to see that data is within a certain range or of a certain type. We've also built a transformation library which works in Spark, and this library has at the moment about 120 functions in it, and it allows you to replicate SQL queries but in Spark with a simple drag and drop GUI interface. And finally, we have done all of this and tied it into Atlas. So Atlas collects all of the information, the governance information in the background. There is no need to program Atlas, or no need for anybody to create entities or anything else like that. What it does for chief data officers is it allows them to automate the movement of data across the data lake. We check the validity of the data. We also have metadata tagging, which we'll show you in the demo, where we allow you to create tags and apply them to the data as you ingest it and as you process it. Because it's based on Control M, we find very quickly all of the errors, and the error detection and reporting is very strong. We allow you to put tags in to control the life cycle of the data, so that data can be expired and can be deleted automatically. We tie it in with rangers, so we allow individual access to the data, and we have tagging again to enforce GDPR compliance as you go along and you go through the process. So that's just the background of what we do. What I'd like to do now is show you a demo of the product. So if you can just bear with me, please. I want to change computers. and it's logged out. Okay. So, what you're looking at here is the Control M screen. So as I said earlier on, what we have developed sits on top of Control M, and it utilizes all of the Control M functionality. I'm not going to go into detail today on what we can do with Control M, but what I am going to do is show you a demonstration of a sample workflow where we've ingested, masked, and transformed data. And I want to show you how easy it is to create that and all that you need to know to be able to do so. Here I'm going to open a presentation that I've prepared already. So this is a sample workflow. And basically what we're doing here is we're ingesting data from 3 tables: a customers table, an items table, and an orders table. These tables are on an Oracle database. The customers data, when we ingest it, we're going to mask the name of the customer and the email address. And then we're going to take this masked data, join it with the other 2 tables, and perform some simple calculations and create a report and a new table on Hive. How this works is, in Control M, everything works off of templates and predefined pieces of automation. And if you look up here, we have created these icons here are all around Bluemetrix Data Manager. So we have a template which allows you ingest from a database. We have a file ingest template. We have an execution on Spark. We have a select template. We have various templates that we've created, and I'll show them to you as I go through the demonstration. So to ingest customer data from an Oracle database, this is what you need to do. You need to drag the template into the workflow, and then over here on the right-hand side, you fill in this information. The first thing you do is you give it a name. You can see the job type is it's a database ingest. You give it a name called ingest customers, and then you define which database you're going to ingest from. This is a once-off setup. You set up this thing one time, and basically it's a connection that we have set up here to an Oracle database, and it's got all of the passwords, the location of the servers, any Kerberos information. It's just a once-off thing, and once it's set up, anybody can use it. When you have that set up, you then input the name of the database, which is XC, and the customer, the name of the table. In this case, it's customers. And where you store it in Hive, and the name of the table. If you want to, as we have here, you can then apply tags to this, which will appear in Atlas. And this is basically all GDPR information, where we can say, we can put in an expiration date, the reason for processing the data, which is compliance. It's not sensitive data, and we have consent. So all of this data is inputted as you ingest it to ensure you're being compliant with GDPR. There's a number of different ingest modes. We can ingest a table fully and overwrite it, or we can append it or delete it and update it. In the case of an append, this would be where you would run the data, run this job every hour, and we would get the most recent data. Then we have a validation stage where you identify a validation job. And what we do with validation is we do 2 checks. We create a checksum, which is a unique hash value of the table that we're ingesting at source. And then when we have it ingested, we run the checksum again and see if the values are the same. And if the data hasn't been corrupted, the values should be the same. And we also have a row count as well. So that's all you need to do to ingest data. And in the background, The system is creating scoop jobs, is creating Hive tables, and I'll show you all of the output later on as to what it does. But that's all, as a user, all you need to do. If you look at one of the next tables, the items table, it's the very same. The only difference is we don't have any tags around GDPR because there's no GDPR data in items. It's only retention data is all we want. So that's all you need to do to create an ingest job on the data manager. Once we have the data ingested from customers, we now want to mask it. So the first thing we do is we create a workflow in Spark, and we initialize that, and when we initialize it, we give it an input, and we give it a job name which is in it, but down here we give it an input, and we say we want you to take the data from the customers table, and it's in Hive. It could be in HDFSF just as easy, but that's where we start from. And then the next stage of it is we take the name, and we basically apply a hash of SHA1 type of hash, but there's numerous different hashes you can apply. So we apply a hash to that, and we overwrite the customer name with a hash value. We do something similar for the email address, where we basically take the email address and we apply a regular expression to it and create something like this. And finally, we create an execute job to execute it all. And when we do this in Spark, we chain the jobs together. So everything happens at the very end. Nothing happens as you go through it. This only all executes when everything is loaded into memory in one time. When the data is masked, we then take it and we initialize a different job around transformations. So again, as before, we create a new job and we call it report customers because it's going to be a report on what the customers purchased. We look at the input of the data. It's coming from Hive, and it's the customer's masked data. So that's what we're going to start with. And then with that data, with that table, the next step is to join the orders table to it. And simply, again, what you do is you specify your input here, your orders table, and the join columns that you're going to join on. And again, you have a number of different join options that you can select. All straightforward with no coding. You have the ability to add tags if you want to, but there's no need to. In the next one, we join the items, and we have added a tag here because what we're also doing is we're storing the intermediate data. So we're taking the three tables and we're going to store it in this new table here, orders joined. And once we have the three tables, we then create a function to calculate the price, which is a straightforward expression where we multiply two columns and we create a new column. And we select a subset of that data to report on. And finally, we aggregate the results. So we take the results of that and we perform an aggregation. And again, we've many different functions we can use here to aggregate the data. And finally, we execute it. And that's it. That's all you need to do to create a workflow. And in the background, I'd like to show you, I ran this job earlier today. Sorry. Just bear with me for a moment. You know, you see this? Okay. Do this, right? Murphy's Law with demos. when we what we do in the background is we basically create code. We create scoop code and we create Hive code and run it to execute the job. And something has obviously happened to our connection here. Apologies. Okay. Is our connection gone? Sorry, our connection has gone to the server. No. Okay, can we look at the atlas? Okay. Sorry, we're just going to check to see what happened with that there. But what we did in the background, we also created a lineage of this job in Atlas. And this is the output that was automatically created into Atlas. And as you can see, I'll just talk it through with you. There's basically three, this is the lineage around the ingestion of the table, the customers table from Oracle. And there's two parts of it. In the first part of it, we import the schema and basically store that on HDFSF. And this is the command that was used to do that. Once that has happened, we then import the data onto HDFSF and we store it on HDFSF, and we go from there and we take that and we store it in Hive. So every command that has been used, that was generated in the last one, is stored and recorded here in the Atlas lineage table. And this is your final table where you've got your new customers' information. Once we get that done, we move on and we mask it. And we join it up here with the orders table. If you remember, we had a second ingest. And finally, we join it up here with the items. And here you have the join of the three tables. This is the data set in Hive. And this is your final result over here. So all of this is recorded automatically in the background. And you get information, you can drill down into it, for example, and get information like this on the customers table that we've stored on Hive. Which will give you all the properties of the data, all of the information on the table, where it come from, when it was created, what you did with it. You have also the tags that we created, which haven't come up with it. We have the audits, when it was done, and basically some schema information as well. So all of this is created automatically in the background in Hive, and nobody has to write any code. The data itself, it looks something like this. This is just a Zeppelin view of the data, where we basically, these are the tables that we have imported into Hive and onto HDFSF, and we keep all copies. So all the staging copies, all of the staging tables are kept during the process. This is, if you remember, we joined three tables. This is a view of the combined table with all of the different columns in it. This is the raw data that was created before it was masked. And this is the final table, the masked data. And this is just an example of a query you can run on the masked data, where we just did a simple query around the order prices and identified people in terms of how much money they spent. So that's an overview of what the Bluemetrix Data Manager does. And I guess if we were to summarize it, I think what it does is a number of things. It removes the need for any resources around scoop or ingest, because we automate all of the process around the ingestion of the data. So there's no need for anybody to actually be able to have to write scoop code or Kafka code or whatever. The second thing it does is it removes the need for anybody to understand the differences in data between databases on Teradata and Oracle and Hive. Because again, what happens is we normalize the data. As we ingest the data into Hadoop, we change it and we change the characters so that we don't break the underlying Hive store. There's also no need to have any SQL knowledge around Hive, because everything is done through a library, a simple drag and drop library around Spark. And finally, we've automated all of the data governance. So that again, no need for anybody to write Atlas code or to store entities. You're not depending on your developers to remember to add data governance to all of their tasks. And what we try to do is make Hadoop accessible to people without having to understand the underlying knowledge of it. And that's the gist of what the product is. Does anybody have any questions around it? I don't know if there are any Control M users in the audience. Sorry, yes? I can't see. Sorry. Are they visible? They're visible from within inside Control M. Inside an Atlas, we record the running of the Spark job, and we record the code that was generated for it. Yeah. So in all of the jobs, we record when it was run, and what code was used, and who ran it. So all of that is stored in Atlas. Yeah, that's a good question. The tagging at the moment is on a table level. We've just added a new feature which we haven't put live on this yet, and it's auto tagging, where we automatically tag all of the data, and we allow you to do it on a column level and tie all of that in as well. That's going to be coming out in the next couple of weeks. We have a beta version of it we have a demo of that on the stand, but we haven't put it into this product yet. We haven't tied it together. We've basically added a data catalog feature to this so that you can have all of your metadata and all of your tags in one place. Yeah. Yes?
How do you deal with breaking schema changes
Well, every time before we ingest data, we read the schema. So if the schema has changed, or if the schema has changed since the last update, then we update the schema on the Hadoop side of things. So for each ingest, there's a schema check before we do anything. Because again, that's one of the problems we've seen, that the schemas change and you don't have consistency between what you have on the data warehouse and what you have on Hadoop. So that's automatically carried out. And again, I suppose just to extrapolate a little bit, the sample here today is about Oracle Data Warehouse. That's only because it's an Oracle Data Warehouse that we're working with. We have connectors that work with Teradata, that work with SQL Server, with any data source. And when we create a connector, we basically normalize that that connector is created to normalize the data between where it's coming from and where it's going to go. So it typically takes anywhere from 1 or 2 days to a week to create a connector for a new data source. It's not a big task. Yes? How the version control? Yeah, Leonardo, how does that work? It's the control.
Are you talking about the lineage, the view of the lineage, or the job itself? So the job itself. Like right now it is like reading from 3 tables. So if I add a fourth one, so it's a new version of the job, right? So yeah. So well, you add a new job for that. All the old jobs is there. Control M, the way it works, it has a history. One of the features, unfortunately, it's not open there. One of the features you have Control M is you can compare outputs of logs of the job that run, all the yarn logs, everything will be there on the job, on the Control M UI the job is in. And you can control from there all the versioning and control the UI from whether the job is just one entity. It has 2 different views, a planning view and a
Sorry, I can't see. What's this? So, sorry. Does somebody have a question there? Sorry. Yes?
Is it possible to implement a kind of delta mode for the ingest without writing code? You understand?
No. What do you mean?
In the normal data warehouse, I implement a staging process where only new data is loaded or change data is loaded.
Yes.
I can't imagine that the jobs you create, you're always import the whole data.
Oh no. Sorry. Yes, it is possible. It is possible. When we ingest a job, let me just. It's not connected, no? Okay. Sorry, we're having a connection issue with this. But when we ingest a job, if you remember, we have 4 types of ingest. One is where we ingest the full table each time. The second is where we do an append. And in that case, what you can set parameters that it's appended from a certain date or a certain time or a certain field. So you can specify what level of ingest that you do, and you can, because it's on Control M, you can specify how often you do it. Is it every 5 minutes? Is it every 10 minutes? Is it every hour? It's 24 hours, and it runs automatically. And there also is an update feature again, and there's a delete feature. So it's fully functional in that way. You don't have to ingest the table each time. Yeah. Yes, it is. What we do is we create a different job type on Control M, because Control M is mainly around batch processing, but we create a constant job that runs constantly, and we take it in and we do the exact same stuff with it. Yeah. Yeah. So that can be either on Kafka or Knifeguy, whichever. Yeah, that's possible to do. Sorry.
It's like batch jobs that you do on a nightly basis, but what about CDC, Kafka Stream?
Yeah, I mean the streaming, and again, Leonardo, you can come in on the specifics of it. As I understand it, what we do is we basically create a constant job that's running constantly in Control M, and it's constantly monitoring the Kafka and taking in the data and basically processing it and storing it.
Yeah, it's basically a monitor that you have for your job. You start it, you keep there. If there is any failure, you restart it, but it's controlling it. That's what you have inside. So it's all about controlling it and keeping off the
To the streaming, yeah, yeah. Yeah, 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 everything. Okay. Okay. Good. Any more questions? Again, apologies that we couldn't show you the actual code, but we're exhibiting at the in the stand. So if you want to see it, if you want to come along, we have it up and running there on live, and we can show it. We didn't want to run a live demo here because we weren't sure of the internet connection to our servers, and turned out it was worse than we thought it was. But we have it running on the stand, and we'll be happy to show it to you, and the type of code that's generated, the log files, and everything else. So if any of you want to see more details, please come along, and we'll be glad to show it to you. No, yes, well, thank you very much for your time. Appreciate you coming, and see you inside. Thank you.